is the second video for chapter 19, and we're going to talk about the oxidation number change method. I'm going to tie up a few loose ends first, and loose ends, basically we're going to talk about the reducing agent and oxidizing agent. So think about this. An element is oxidized. If it's oxidized, it loses electrons. If it loses electrons, that means that something else is gaining. So when it loses, it gives its electron to something else, which makes the other thing reduce. That's where the term reducing agent comes from. It is the thing responsible for reducing something else. Same thing with oxidizing agent is if I'm an element and I'm taking electrons, I'm making something else lose them, so I'm the oxidizing agent. If that doesn't make sense to you, the easiest way to do this is to think in terms of opposites. So whenever something is reduced, it's the oxidizing agent. Whenever something's oxidized, it's the reducing agent. Easiest way to think of it. The other is just to make sure that we've talked about hydrogen and the way it's involved. Mostly with the original ideas about oxidation and reduction. Remember that originally oxidation was the adding of oxygen, reduction was the loss of oxygen. Well, hydrogen was involved with all this too, and in the early research they saw that when you added hydrogen, it caused a reduction. When you take away hydrogen, it caused an oxidation. You know, if you were asked the following equation, if you had to label it with one word and you were adding, it was adding hydrogen, well, that would be a reduction. So maybe make a little card that helps you remember that, do a flashcard. All right, the other thing is that another method, a third method for determining what's oxidized and reduced is to look up electronegativities. You'll have an electronegativity chart in the middle of the back, right up above the polyatomic ion chart, and that electronegativity value, remember what electronegativity is. It's the tendency to take electrons from a neighboring atom. So if it takes electrons, when it has a high electronegativity, it's going to be gained, right? Gained electrons, gain electrons reduced. And if something has a low number, then it will tend to lose electrons and be oxidized. So look up the electronegativity numbers if all else fails, especially when you're given a compound and it says which of the sides of this compound will be oxidized, which will be reduced. Look up the electronegativities. So that should be the loose ends. We're going to move on and talk about the oxidation number change method. So last time we talked about the change method. We've already got the change method down. It's just we're going to add a couple more steps and use it to balance. So remember that you go through, first thing is make sure you have a good skeleton equation. Above every capital letter, write oxidation number. Once you've written the oxidation number, then you're going to look and find the one thing that goes up in oxidation number. When I say thing, I'm talking about one of the elements will go up between the left and the right side, and one will go down. You're going to make a bracket to connect the, kind of like a bridge to connect the one that goes up on top and the one that goes down on the bottom. So in making that connection, now we know which are the main two that we're going to balance in the number change method. So this is one we're going to practice. It's in your notes. It's iron 3 oxide plus carbon monoxide gas yields iron solid and carbon dioxide. We're going to go ahead and draw this one up. Fe2O3 plus CO yields Fe plus CO2. Okay? So that example, we're going to go through and assign oxidation numbers. Now, on most ionic compounds, you can uncrisscross. There's a 3. That came from the iron. The -2 came from the oxygen. And you can double check that. 3 times minus 2, minus 6. This has to be 2 times plus 3. Minus 2 plus 2. Iron is 0 because it's an element by itself. Minus 2, 2 times minus 2 is minus 4. We need a plus 4 here. So, what went up? Carbon goes up, plus 2. And in the parentheses, we're going to put a plus 2 to say it went up plus 2. And the item that went down would be iron. Okay, so carbon goes up, iron goes down. So we go from plus 3 to 0, which would be a minus 3. That's our number in shields. In brackets or parentheses, we can't change it. It's part of what happens with the reaction. We can't lose 2 electrons and gain 3. It's got to be balanced. It's like going to a convenience store. You hand somebody $20 for something. They don't get 10. They get 20. Okay? Now, they may try to convince you they got 10, but, you know, that's a ruse. So the idea here is that we've got to be losing the same number that we gain. How do we do that? With the x number. 3 times plus 2 equals plus 6. 2 times minus 3 equals minus 6. Now, we're losing 6 and we're gaining 6. We use that number, we're going to call it the x number, the times number, in order to make the two equations equal and opposite. And they will usually be a different number, but the product will be equal and opposite. That's what we're striving for. Now, take the x number and follow the bracket to the element, not the compound, but the element. In this case, iron. The x number is 2, so 1, the coefficient, times 2 equals 2. This has no subnumber, so we put a 2 times 1, okay, 1 is understood as a subnumber, to equal 2. Now we go to the other one. We have a 3. CO, we're not worried about the O, we're just worried about the C. C has a 1, so we put a 3 in front of it, and we put a 3 in front of that one. We have made the element equal to the x number when we multiply the coefficient times the subnumber. In this case, everything's connected. We're done. Okay? Method's not that hard. Now, in some problems, there will be an example where it's not connected. There will be more than 4 substances. See, we've just got 4, so we've got 1, 2, 3, 4. If there's something not connected, then all you have to do is balance that separately. And what this does is it forces part of the equation to be balanced so that all you really have to do is just finish up 1 or 2 things. And the reason we need this method, yes, this one would be easy to balance in 20 seconds without the method, but when you have oxygen in about 3 or 4 or 5 different compounds, you don't know which oxygen to change. This method forces the bulk of the equation to be balanced, and then you'll have just 1 or 2 things left, and it's easy to make that decision. Okay, there are some practices on the practice page. I've got like A, B, C, D, E, F on the front, and then I've got all the total solutions on the back. I recommend you work through some of those in order to get some more practice doing the number change method for balancing. Now, the other thing the number change method does is it tells us what's oxidized and reduced, and we did that last lecture. This was plus 2. Minus a minus makes plus, so losing electrons is oxidized, and the one that's reduced is reduced. The number reduces. Okay? So, get some more practice on that. Come in for some help. We're going to talk about, there's some more on the notes also, another screen or two that shows you the results of this one. And then we go on to the half reaction method. Now, on the half reaction method, if you look at the back side of that last set of notes, I have a practice problem there. If you don't have those notes, look in your text on page 694, table 6. There is a practice problem there that takes you through the half reaction method. So we're going to put this up on the board, and I'm going to work through it. And I suggest that you look through that page or the table 6 in the book so that you can follow through. So on the half reaction method, the first thing is we've got our equation. So we've got Fe solid plus CuSO4 aqueous produces 3Cu plus Fe2SO4 3. So that's our equation that we're starting with. First step, just like when you drop something, it breaks into its pieces. When we put these ionic compounds into solution, they dissociate. So Fe is by itself, it's already where it's going to be, plus Cu, 2 plus. We know it's 2 plus because there's one of them. There's a 2 minus on SO4, so it has to be 2 plus. So that, and these are all aqueous, plus SO4 2 minus produce Cu, and we're just doing the non-balanced form. Okay, that should have that balanced already. Cu plus Fe3 Fe3 plus. So the basic idea here, oh, and we've got plus SO4, we've got 2 Fe's and we've got 3 SO4s. So the idea here is that we've just broken it into parts. Next step is we get rid of the spectators. SO4 doesn't change any, it stays the same, so it's still SO4 2 minus. They're not changing any, they're not involved in the reaction, so we're not going to make any changes on it. So the next thing that we do is we figure out what's oxidized and reduced. Well, we start out with iron is 0, and we go to iron is 3 plus, that one goes up, so that one's oxidized. So we write it over here in a separate half reaction, iron to Fe3 plus, that's oxidized. That's oxidized, so our other reaction is going to be Cu2 plus, and that goes to Cu, and notice that that goes down, it's reduced, so it's reduced. All right, problems, one is that we've got 2 Fe's, and we don't have, but we have but one over there, so we need to balance that. Now we've got those balanced. The other thing is we've got 2 times 3 plus, charge is not balanced. So we have to have 6 electrons over here. We balance the elements and we balance the charges. This side we've got 1 and 1, so we're good there. But the problem on this, in this case, we've got a 2 plus and a 0, so we have to add 2 electrons to this side. Now we've got the charges balanced, we've got the elements balanced, but there's one other problem. We've got 6 electrons being lost, we've got 2 being gained. And this is much like the oxidation number change method, that we have to fix that. And this is the point where we fix it. Well, how do we do that? If we're losing 6 and we're gaining 2, we just have to gain 2 3 times, which means we need 3 and 3, so we do gain 2, gain 2, gain 2, and that balances with the loss of 6. So we're going to write 6E minus here. Now we've got it balanced. We put them back together and we add the sulfates back in, and that gives you the final balanced equation. This is probably the easiest of the problems you'll see with half reaction method. We'll talk about some where we have acid in the solution and base in the solution, and that adds one more item that we have to look at. That will finish up what we're talking about on this this lecture, and do some practices, find some practice in your book and on the practice pages to finish up. Good luck.